Hey everybody. So this is video one, even though I'm recording it second, but that way I knew what was going to be in video two. So this is video one. It is for Unit 4, Subunit 1, and I said this already in the email, and I'll say it in video two. Just because you are listening to the video or watching me do this doesn't mean you shouldn't be in the notes, because the notes are still I'm not going to talk about everything in the notes, some of the self-explanatory stuff I'm just leaving go. I'm trying to keep this video under 10 minutes or something so I can upload it at a reasonable pace. So anyways, make sure you're still reading the notes. Make sure you watch video 2. It'll be a visual explanation of some of the stuff, and you don't just get to look at my lovely face. So the whole of Subunit 1 for Unit 4 is about taxonomy. And really what that is it's a classification system for organisms. Some of those names are going to be familiar to you. Words like plant, animal, reptile, mammal, words that you guys know have roots in taxonomic classification, taxonomic naming. So some of those things are going to be words that you guys are familiar with. The current system we use for taxonomic classification was created by a guy named Carolus Linnaeus in the 1700s, and a lot of the words are in Latin because that was kind of the common tongue of the time period. So like I said, reptile, but the word in taxonomy would be reptilia. Mammal, but it'd be mammalia. So that's the sort of like the Latin words that some people get turned off by in learning taxonomy, but once it's something that's normal to us, it's not that big of a deal. On a basic level, we're going to talk about 7 different groups or categories of taxonomic classification to classify organisms. Those 7 parts are kingdom, phylum, class, order, family, genus, and species. At some point in the past, you guys may have had to learn something that was I don't even remember what the phrase is because I just have it memorized, but it was King Philip can something. It was a way to remember the 7 groups. But there can't be more than 7. In video 2, I talk about a subspecies. In that example, it would be kind of an 8th level. So anyway, so those are our 7 levels of taxonomic classification. Like I said, there can be smaller separations giving it more than 7 levels. I've seen as many as like 40 levels used, if you're talking about a lot of levels between the levels, so to speak. An example that I didn't put in video 2, in between the phylum, which was Chordata, and then the classes, you could have a subphylum, so it's like a level between phylum and class. It could be vertebrata, so the things are vertebrates. All the things in video 2 would have been in vertebrata. Anyway, so like I said, make sure you guys are reading the slides in the notes. What I'm talking about right now is going to be found on pages 3 and 4. You should know the 5 kingdoms that's in those slides. Animalia, Plantae, Monera, Protista, and Fungi. Those are the 5 kingdoms that's in the notes. You should also know that an organism's taxonomic name can be referred to as its binomial nomenclature. We also call that the scientific name. So that's the last 2 parts, the genus name and the species name for any organism. We've already said that ours in this class is Homo sapiens. That is your, quote, scientific name. So that would be your name through binomial nomenclature. The genus name, which would be Homo, and then the species name, which would be sapiens. And the name binomial nomenclature should make sense. Bi, two, nomen means name, so it's like a 2-name system. And like I said, that's also called the scientific name. And on video 2, we'll start looking at the full taxonomy of a few species and a couple examples that, again, make sure you guys watch video 2. So really there's 2 good reasons, well there's probably more than 2, but there's definitely 2 main reasons for using taxonomic classification. The first one is to see how closely related different species are. and I'm going to show that with a framework. We'll talk more about that in a second in video 2. And the second part is so that you can know if you're talking about the same thing, or if other people, like if you're talking about the same thing with somebody else and you're just using different, what we call common names. So the first thing, the frameworks, I'll talk about more in a second. Let's talk more about the common names issue. So let's say you and a couple of friends are sitting around and you're hanging out in a backyard or something, and you see one of those brown, kind of big rodent-looking things, the things that are supposed to be able to predict an early spring if they see their shadow on February 2nd. I think probably everybody knows what I'm talking about now. And maybe one of you call it a groundhog, and somebody calls it a woodchuck, and somebody else thinks that it's a marmot, and then a fourth person calls it a whistlepig. When those are 4 different common names for that species, but so long as you're in Ohio, all 4 of those people are talking about the same thing. Its scientific name through binomial nomenclature would be Marmota monax, and I think in Ohio we technically call it a woodchuck, but groundhog is commonly used too. It's that thing that if you have a farm you probably trap or shoot. So that's a real good value of taxonomy, because in different regions or different just localities, we call things by their common name, and sometimes common names are different things. Let's see. I don't know if you've ever heard of a skunk called a wood kitty. It'd be a different common name. Hello. If you guys have heard any clicking, it's my dogs. Come here. Here you go. Greta. Okay. Here's your guest star. Okay. Yeah, that's them walking around on the floor. So anyways, if you can think of different common names for a given species, there's a lot of them. I can't think of anything else specifically right now that's kind of almost like a slang name for a species. You guys can probably think of a couple of those on your own. So anyways, back to frameworks. So what a framework is, it's a physical chart or graph that's going to show how closely related different species are to one another. And you could go back to thinking of speciation, like how closely related these things are through speciation. And the framework is like a physical chart that shows that. The more levels that 2 different things share, the more closely related those 2 different species are going to be. So if they only share the same kingdom, phylum, and class, they're not going to be all that closely related. But if they share kingdom, phylum, class, order, family, and genus, they're going to be pretty darn closely related, and you guys will see a little bit of that in video 2. The majority of video 2 is all about a framework. So the final thing in the notes that isn't fully explained by the notes themselves is the food web or food chain part. But you should be pretty familiar with a food web or a food chain. They both show energy flow from one organism to another. The arrow goes to the consumer, so the arrow points to the predator, if you will. But if it's a deer eating grass, it's just the consumer. We don't really think of the deer as a predator. And so a food chain is just that. It's a chain. It's a one-way, this thing eats this thing, which got eaten by that thing, which got eaten by the third thing, or the fourth thing, or however many I just said. So it's a little bit simpler. The food web is a little bit more complex. It shows like a community of kind of who's eating who. Maybe one thing is eating 3 or 4 different things. So a food web is a little bit more involved than a food chain. The thing to remember with both is that the arrow goes to the consumer. So that's probably the number one thing that kids mess up on this, is they just don't pay attention to what they're doing, and they don't draw the arrows the right way. So again, the arrow points to the consumer. So if you have grass and a deer, the arrow points to the deer. The deer, the arrow shows energy flow. The deer is getting energy from the grass. So the arrow goes from the grass to the deer. And if you mess that up and you have your arrow going the wrong way, you have some really like vicious grass. The deer's out there just having its whatever, and then all of a sudden the grass lurches up and eats the deer. Doesn't seem likely. Make sure the arrow goes to the consumer. Other than that, I said this, I'll say this in video 2 also. Make sure you guys are reading the notes. These 2 videos are not all about the entire notes packet. There are many things, vocab terms, things we haven't discussed in the past that are in the notes that are not in these videos. I was just trying to keep these videos to not that long of a time period. So I'll make up like a study guide sort of thing and send that out to you guys also. But make sure that you watch video 2. Make sure that you guys read through the notes. As like I said, there's going to be vocab terms and things that are going to be on your test that will not be covered in either of these 2 videos. So I hope that helps you guys out. If you have questions about any of the content on either videos, feel free to send me an email. I can kind of straighten out anything that maybe didn't make perfect sense. This is a really hard section for me to do this electronic-based learning on, just because it's something that's totally new to you guys, and I can see it being complicated if, again, this isn't a super in-depth description. This is something that we would spend days on in class, just me going over kind of how this looks, how you put this together. And we can't do that. But if any of you folks are going to end up taking Bio 2, we do a lot with frameworks in Bio 2. Like I said, I think it's a great way to learn more about just the whole ecosystem, knowing how things fit together, being able to physically look at it in a framework, seeing how closely related different mammals or different amphibians or whatever, how closely related some of those things are. So if you guys are going to be in Bio 2, this is going to be something that we'll do a lot. So if you think this is not for you, Bio 2 might not be for you. So like I said, if you have any questions, let me know. Hope everybody's doing okay. And I think everybody, probably like me, is on pace for a haircut at this point. So anyhow, so we will talk to you guys later. Like I said, if you have questions or concerns or comments or anything like that, email. Let me know. See you.